Okay, guys, so for today we are talking about just integration techniques, which ideally would be easy, but is one of the harder things that we've got to do, is just to look at a function and figure out how are you going to integrate it. So when you are thinking about integration, this is kind of the order you should think through it in. So first thing, we want to just see, can we use a regular rule? So just a power rule, trig function, ln, e, something that's easy to identify. Can we just use a regular rule? Usually, though, that is not the case. So if things are divided, meaning you've got some sort of fraction that you're working with, you have two options. What you want to check for first, if you have a fraction, is can you use u substitution? Pick out what your u is. U is usually the something that is on, now I say usually, u is usually the thing that's on bottom in parentheses or in an exponent. But in general, it's going to be like the more complicated kind of looking function. It has more parts to it. If you can't use u substitution, then you are going to use partial fractions, where you factor the bottom, split it into two fractions, solve for the a and the b, and then integrate. And remember, with partial fractions, you will always end up with ln in your answer. Now third, if it is multiplied, meaning you got two functions that are multiplied together, the first thing you still want to check is u substitution. The second thing could be by parts. And that can still be kind of confusing to know which one you're supposed to use. So what you want to look at is the power on the inside and the outside. If those powers are where the inside is greater than the outside, you're probably going to end up using u substitution. For by parts, if the inside is less than or equal to the outside, you're going to use by parts. One note with by parts, remember that if it has ln, you have to use the formula. And the formula was the thing that was not quite as fun to use, but it was still fine. So let's kind of look through an example of each of these, and I'm not necessarily going to go in order because I want us to actually have to look through this and figure out which method we're going to use. Okay, so let's first look at integrating x squared ln of x dx. So right off the bat, it should be pretty obvious that's not a regular rule. We have things that are multiplied together, so we're going to jump down here, and we want to compare the inside power with the outside power. So the inside power is 1, the outside power is 2. So the inside is less than or equal to the outside, which means we're going to use by parts. And since it has an ln, we get to use the formula. So the formula is the integral of u dv is equal to u v minus the integral of v du. And then we need to remember, when you're using an ln, that is always the u because we can't integrate ln, which means dv is x squared. So du, we take the derivative, and that's 1 over x dx. dv, we take the integral, and we get x cubed over 3. So now we're following this part of the formula. So uv, I'm going to put them in the opposite, or sorry, that was the wrong thing. uv, I'm going to put them vu though. So x cubed over 3 ln of x minus the integral of v x cubed over 3 times du, which is 1 over x dx. So this part is not going to change. But this inside we can simplify. x cubed over x, one of those x's is going to cancel, and now we have x squared over 3 dx. So we still have x cubed over 3 ln of x minus, we add 1 to the power, divide by the new power, so 3 times 3 is going to give us 9, and then at the end we need a plus c. So that is one of our examples that we're looking at for integration by parts. So 2, let's look at this one. So when we start looking at this, we want to try to work through our steps here. There's nothing multiplied together. We have a fraction, but in terms of fractions, we're thinking of like functions being involved. So there's no functions involved here. So it's probably just a regular integration rule. So this can be rewritten as 5/3 x to the 2/3. And so now it should be obvious it's a little more of a power rule situation. So we have 5/3 x to, we add 1 to the power. So 5/3 divide by the new power, which is 5/3. So we just end up with x to the 5/3 plus c as our answer. But that's, again, usually not the case on the AP exam. So let's now look at ln of x over x. So we have things that are divided. So we can focus in on that part, and I can't draw a star to save my life, apparently. So we are trying to figure out, are we going to use substitution or partial fractions? Now, partial fractions is typically like polynomial over polynomial, and that is not the case here. So it's likely going to be a u substitution thing. So I did say with u substitution, it's generally whatever's in the bottom. This is kind of the exception to that, because if we put u equal to x, the derivative of x is just 1, and that doesn't help us out. But if we do u as ln of x, that means du is 1 over x dx. So ln of x is u, 1 over x dx is du. So when you rewrite this integral, it's just going to be u du, which is a power rule thing. So u squared over 2, we plug back in our u, and then we need the plus c at the end. Okay, so now fourth example, we integrate 12x plus 12 over x squared minus 4x dx. So again, we have things that are divided. We really still want to check u substitution first. So if you tried to do u, you would make it equal x squared minus 4x, which means du would be 2x minus 4. There's nothing that I can multiply this numerator by to make it equal 2x minus 4. So that means u substitution is not the route we want to take here. So we're going to have to do partial fractions. So when we factor the bottom of this, there's only 2 terms, so we just factor out what they have in common. And then you split this into your 2 terms. So then remember, you multiply by the denominator. So that means the x's are going to cancel here. And then the x minus 4's are going to cancel here. So from there, we want to plug in our zeros. So the one that makes b 0 is when x equals 0. So when you plug in 0 for everything, that's going to give you 12 equals negative 4a plus 0, which means a is negative 3. If you plug in 4, 12 times 4 is going to give us 48, plus that 12 is going to give us 60. The a is going to be 0, and then we'll get 4b, which means b is going to be 60 divided by 4, which is going to give us 15. So we would take those and then plug them back in. So we're going to get negative 3 over x plus 15 over x minus 4. So we integrate that, and remember right here we said it always ends up in an ln. So this first one is going to be negative 3 ln absolute value of x. The second one is going to be 15 ln absolute value of x minus 4. That's really messy. I don't like how that's written. So negative 3 ln absolute value of x plus 15 ln absolute value of x minus 4 plus c. So those are all our different methods of integration. There's just a couple things that I want to remind you of. So I'm going to give you a minute if you are jotting down anything here, not that you had to, before I get rid of some of this, because there's a couple notes I want to make. So with partial fractions, so partial fractions specifically, if you ended up with an answer that looks like 4 ln of x minus 2 minus 4 ln of x plus 7, on the AP exam, they are going to combine those. Since they have the same coefficient, this is subtracted. That means they're going to combine into division. So you need to make sure that you remember that. If, same thing, but it was a plus, they have the same coefficient, it's plus, so they're going to be combined into multiplication. So those are some things you need to remember there. Then lastly, just I wanted to kind of run through real quick another partial, or not partial fractions, another by parts one, but just to remind you of the chart method with it. So remember, this one doesn't have an ln, so with your chart you do the sine, the u, and the dv. So the sine always starts positive and then alternates. Your u is the thing that gets simpler, so your x squared, 2x, 2, and you stop at 0. And then your dv you take integrals of. And then remember, when you go to write your answer, you take the first 2 and multiply it by the diagonal 1. So our answer here would be x squared e to the x minus 2x e to the x plus 2 e to the x plus c. I'm going to do another real short video on improper integrals. So if you will look over at that, then you should be good to go on everything that we're doing today.